CCI, Crash Course Instrumentation, presents episode number 37, Amperometric Sensors. I, Light and Radiation, Current-Making Sensors. Fresh after Ep 36 Hall Effect. Today we meet amperometric sensors that produce a small electric current when stimulated. We will focus on our light sensors, photodiodes, phototubes, and give a plain English peek at our radiation counters. Open hook. Shine a flashlight on a solar cell and a current appears. Aim a photodiode at a barcode scanner and the signal rises and falls with the stripes. Expose a Geiger tube to a calibration source and you hear clicks from tiny current pulses. All three are amperometric. The sensor's output is a push current that represents how much. What amperometric means, plain English. The sensor makes current instead of just changing resistance or making a standalone voltage. We usually convert that tiny current into a voltage with a resistor or a Transimpedance Amplifier so instruments can read it. Because signals are small, we care a lot about noise, shielding, and a clean wiring. Photodiodes, the workhorse of light sensing. Light hits the junction and frees charge carriers. The device produces current, roughly proportional to light level. Two common modes: photovoltaic, no external bias, slower but very low noise, and photoconductive, reverse biased for speed with a bit more noise. More light, more current, cover it with your hand, current drops toward the yet dark current, the tiny leakage with no light. Different materials see different colors. Always check the wand spectral response curve when choosing a device. Readout tips: use a Transimpedance Amplifier for precision or a Shunt resistor. For quick demos, keep leads short and wand shielded from switching noise. Phototubes and Photomultipliers, legacy but useful ideas. A phototube frees electrons from a metal surface when light hits. A photomultiplier multiplies those electrons through a chain of diodes to make a bigger pulse. They are extremely sensitive for very low light but need high voltage and careful shielding. Modern systems often use photodiodes instead when possible. Radiation detectors, plain English peek. A Geiger-Muller tube is a gas-filled sensor that makes a brief current pulse when ionizing radiation passes through and conducts the gas. Counting those pulses per minute gives a rough measure of radiation intensity. More advanced ionization chambers and scintillation counters also produce a current related to dose. Safety first, never seek radiation sources. Follow your site's rules, qualified training, and approved calibration procedures. Signal conditioning, making tiny currents usable. Use a Transimpedance Amplifier to turn nanoampere or microampere currents into clean volts. Add BAC optical filtering to block unwanted colors and mechanical baffling to cut stray light. Mind offset and eye drift. Let the circuit warm up or zero it before measurement. Separate light sensor wiring from the variable frequency drive and motor cables. Use twisted pair and shield wisely. Choosing an amperometric light sensor. Quick checklist. Range and sensitivity. Can it see the dimmest level you care about without saturating at full light? Speed. Barcode readers and encoders need fast response. Level sensing in a tank may not. Spectral match. Choose a device that responds to your light source: infrared, visible, ultraviolet. Temperature and environment. Check drift, sealing, and window materials. Packaging and optics. Lens, window, and housing make or break the measurement. Mini-lab, safe and simple. Connect a photodiode to a multimeter in microampere mode. Shine a phone flashlight. Cover with your hand. Chart current versus distance. Swap a resistor in place of the meter and measure the push voltage across it. Plot light level versus voltage and discuss linearity. Troubleshooting, field realities. Noisy readings. add shielding, shorten leads, lower the resistor value, or switch to a transimpedance amplifier. Ambient light leaks. Use a shroud or narrowband optical filter. Saturation or clipping. Reduce light, change gain, or choose a larger area device with higher current capacity. Drift at warm-up. Allow a minute for the amplifier and sensor to stabilize, then 0. History nugget, memorable. In 1873, experimenters noticed selenium's resistance dropped with light. Decades later, understanding the photoelectric effect unlocked modern light sensors and set the stage for today's photodiodes and even solar power. Wrap up, what to remember. Amperometric means the sensor makes current proportional to the stimulus. Photodiodes are the everyday choice for light. Radiation tubes make countable current pulses. Good optics, shielding, and odd transimpedance. Readouts turn tiny currents into trustworthy numbers. Credits in CTA. Huge thanks to Tony Kupalt and the open source community for the instructional models behind Crash Course Instrumentation. If this helped, please like the video, subscribe to Crash Course Instrumentation, and share with a classmate or coworker.